Test, test, test. Perfect. I'll leave this up for a second. Just makes it a little bit easier for me to organize. That way I can just go to the first few seconds and know which class this was.
I can tell you that Python seems a lot easier than Java so far.
Yeah, it's there's like no perfect language. Everything has its trade-offs, but yeah, Python's a good general purpose language. So it tends to be my default if I'm doing a new project and I really don't know the scope or how fast it needs to be or anything like that.
Right.
These days, I pretty much just default to Python, and I know a lot of other people do. So it's definitely a useful class. Out of all the programming classes you take, it's probably one of the most useful. So, what's your long-term goal? Do you plan to go into programming or
I'm doing
general
a
IT?
cybersecurity degree, but I have a friend who's already developing games, and I want to help him eventually.
I gotcha. Um, and what environment and game engine and stuff are you looking at?
Um, well, I've been working with my friend Nate. We've been using Godot,
Okay.
which is just a free engine.
Yeah, I've heard of that one before. What language is its main language? Is that Java based?
I think so.
Okay.
It's kind of weird because like Java, like to do the system out, you have to use like the capitalized system and stuff like that.
Yeah, Java's a very, very formal language, so everything is in like a taxonomy almost with namespaces, and so things aren't just as easy as print. It'll be like, okay, in the system namespace out dot print ln, yeah. There's one that, so I try to at the end of the semester get a little bit more free form. Sometimes I'll let everyone do a little project of their own. There's one for Python called Pygame. It's not super great, but if you want to do like a little simple project with it, it might be worthwhile.
Okay, what is it?
Pygame. It's not a full game engine, so they don't offer physics and that sort of stuff.
Right.
But it kind of lets you do movement on screen, and so it's good for like things like this. If you wanted to do a Space Invaders clone or something like that,
Right.
it's good for those types of things.
Yeah, my friend, as a project, because I went to high school with them,
Mm-hmm.
and we took advanced placement computer science principles,
Yeah.
and the language that was taught was MIT App Inventor, which
Okay.
is block code, which is like really kind of annoying now.
Yeah.
Making regular programming classes. Well, he was the one guy that like went off the beaten path and found Godot on his own and did it.
Yeah.
He made so it's a bunch of squares, right? You have to like go through like almost like an H shape.
Mm-hmm.
And he actually made the physics and he made momentum, so like when you stop, you don't just stop, you like
Yeah.
slide forward and stuff like that. And that was his end of the year project for the class.
Oh, very cool. Yeah, that's what I don't do much game programming, but that's what I always tell people is, in my opinion, is like it's a very, very useful exercise because have you ever taken like a high school level or first semester physics class or
Yeah.
trig or anything?
Yeah.
That's all the math you need for 2D games. It's
Mhm.
super, super simple. So that's why it's fun not having to rely on a game engine for 2D games.
Right.
It's like you just need high school physics and trig. So
Yeah, that was really fun. He's actually been working on that game, the end of the year project thing now for a long time. I
Mhm.
helped him out a little bit with like floats and stuff like that.
yeah,
But other than that, I mean, it's incredible because it's not really like, while it is a full game engine,
hmm
it's not a super complex game engine, you know?
yeah,
It's
like
not a lot of fancy applications and things that you can pull.
yeah,
So the fact that he's done what he's done with it so far is really cool.
yeah, it's very cool. So yeah, maybe you can do that at the end of the semester with Pygame. The tough thing with Pygame is that in Python programs in general, you can't really easily compile it down to an executable.
Okay.
And so what happens is that the person has to have Python on their computer. So it tends not to be very easy for me to give people my Python script and tell them to run it because then they have to download Python and you
Right.
can make executables, but the executables it makes are so huge.
Oh, they're like really big?
They're like, yeah, because it has to include the full Python interpreter, and so
Oh.
even a simple program will be hundreds of megabytes.
Oof.
Yeah, so I don't tend to do that very often.
That's like how the JDK comes installed with the JRE.
Yeah.
Yeah.
So.
'Cause
But
I was actually looking at it because I have Chad Calvert as my Java professor
yeah.
online, and he he recommends the IDE NetBeans.
Yeah.
NetBeans 8. And but I was that guy that wanted to try and use Java from the command line for the first assignment just to see if I could do it.
Yeah, it's a good exercise. I usually recommend it to people who are willing to do it.
It took me forever. Cause so you know how command line is like kind of like grainy almost looking, and you can't really like tell sometimes. Well, that's the thing about the capitalization is I was messing up the system.out because I used lowercase s because like all the like print in Python and like the couts and C++, they're not capitalized.
Yeah.
So I was getting that messed up, and it was basically just leaving an arrow at the period at the system out. It was the system.out. It was leaving a period in between them.
Yeah.
I didn't know what I was messing up.
There's a halfway decent terminal because I do most of my programming in Linux, and they've got a bunch of terminals. But this one seems to be pretty popular with in the Windows world.
Okay.
The regular cmd.exe is not great.
No.
This one is getting some popularity, so you might want to check this one out. I guess they pronounce it Commander,
Okay.
CMDER, but that might help a little bit with the readability of your console. Okay, so I think this is as many people as we're going to get, so let's go ahead and get started. Streaming, everything's good. So I just want to get right into it this week. I think nobody has any questions about, and everyone was here last week, right? You got the syllabus, you got all that overview information. Okay, so let's just get right into it. So as you remember, so a couple of notes. First of all, everyone did the attendance thing, right?
Yeah.
Last week, everyone's good with that. All you had to do was click submit. You only have to do it the first week, so you'll never have to worry about it again. You'll notice here that I give you a first assignment. Normally I give you 2 weeks, but the general consensus is to try to give you as much feedback in the beginning of the semester as possible. So this first assignment, I just give you a week, but I think most people in here should be all right. And it's due at midnight, so you have, today after class to ask any questions, the full week to work on it, and then next week during class, if you have like some final questions, you can.
Oh, wow, that is a long time.
Yeah, so it turns out to be, because it's due at 11:59, so it turns out you have a good amount. The directions won't make sense just yet once we get to that part of class, but this is actually directly based on another example in class, which is a theme you'll see with me. I try not to, it's like I give you a problem and then I just kind of move the problem a little bit over to but it's usually pretty obvious what's going on. So, okay. So again, in this class, we're going to be using REPL, but you're welcome to install your own Python interpreter and go that path. This one to me is just the one that gets everybody up and running the quickest. So let's go ahead and do that. And then if you are, if you have your own account, go ahead and make sure that you're logged in so that it saves your code. Can everyone see that, or would it help if I turn the lights a little bit lower, or is that okay like that? Okay. Now, this isn't a recommendation just for this class, this is all programming, is that when you're learning a new language or you're new to programming in general, I generally suggest having very large fonts because it makes mistakes a lot easier to spot. So I'm going to make, for my own purposes, I'm going to hit Control plus a bunch of times so you see the code up there, but you might want to do Control plus a couple of times on your own computer just to get that font a little bit larger. So last week we did a couple of print statements. And again, the best way to think about this would be like your terminal screen. The types of programs that we're writing aren't like graphical programs. They're all terminal based, command line based. And so this would be the equivalent of that. It's kind of like virtualized. And then this is going to be your code area where you actually write the code and then you press play to run it. So the print function, if you remember, make sure I'm streaming okay, I haven't dropped any packets, perfect. The print function prints stuff out to the screen. You probably remember functions from COP2030. We'll talk about functions again later, but that's all that is a function. And remember that these single quotes and double quotes tend to be interchangeable. Whatever it is, like you can't mix a single and a double, but you can do 2 singles or 2 doubles. I tend to stick to the singles just because it's like the difference between having to hit the shift key and not. It's a very minor thing, but it's just slightly faster, so I just catch myself doing this a lot. But they are interchangeable. Remember we have variables here, so I'm going to set this variable name to Chris. You can set it to your own name. Now, one way that if we wanted to say hello, Chris, one thing that we could do is we could use this plus sign and the variable name. I don't particularly like this anymore. In more recent versions of Python, what they've added are these things called F strings, F as in Frank. Imagine it stands for formatting. And what you do is you put a little F at the beginning of that string, and now anything you put between curly braces, it'll interpret as Python code. So I can put a name here, and it knows, you don't mean the word name, you mean the variable name. You don't mean the string name, N-A-M-E. You don't mean those characters. You mean, look at the actual variable name, and it's got a value of Chris. Now this becomes useful if I wanted to do something like this. So if I didn't use, I'll just say GPA colon. So remember the different data types we're working with. Essentially, you can boil it down to numeric data types and strings. There's more, but we'll get into that later. So Chris was a string. It was a string of characters. However, GPA is numeric. It's actually a float. And this special thing right here, if I try to add together a string and a number, that doesn't really make sense. Python says, I don't know what to do with that. So that doesn't work. That's why I generally just stick to F strings these days, is because it's a little bit simpler. And the only reason I even bring that up is because there's a lot of Python code out there that still uses that plus symbol to concatenate things together. So if you see that, just be aware that you can rewrite that using F strings if you want to. F strings are relatively recent. I think they appeared in Python 3.6, which is so maybe 3 years old or something like that. They're relatively new.
A lot of Python code is very old.
Yeah. I heard a story about, I can't remember, it was some financial firm that they were having huge difficulty because they embraced Python maybe 10 years ago, and they wrote a lot of Python code and never, they just stuck to that Python version, and now they're having difficulty because those versions aren't supported anymore. And so they've got a bunch of code that they have to decide how to upgrade.
Ooh, that sounds like a big project.
Yeah. Okay, so we've got some print statements. So print is output. If we want to get input, there's a function called input. Let's do this. I try not to do too much on any one of these tabs. So I'll leave this up for a few seconds, make sure everyone has this typed, and then what we'll do is we'll open up a new REPL. So this was mostly to deal with output. Then we'll open a new REPL that deals with input. And let me do one more thing with this. So let's just print. There's a function called type. It gives you the type. So give me the type of the variable name and give me the type of the variable GPA. And you can see here that the type of the variable name, this up here, is a string, which should make sense just from your experience in other programming languages with strings. And you can see here that this is a float. Now, if you're not familiar with float, float is very similar to a double. It just has to do with the precision. You can think of it very generically as decimal, even though it's not quite the same. We'll do examples later to show you why they're not actually the same. And I always give this warning, never use floats or doubles for money, because you'll end up with these weird errors where you're off by a penny, because it's not an exact representation. But for simple purposes, you can think of them as the same. Okay, everyone's good? So let's open up another tab here. So now let's talk about input. So in this previous example, I had hard-coded name. But what if I instead wanted to do this? I wanted to get the name from the user. So there's this function called input, and what it does is it prompts you. So if you're doing C++, you could think of cout as the print statement, and then input would be like the cin. You use it slightly different because they're actually functions. And so we would say enter name. Well, where is that stored? It actually gives you that result. So we would say name equals, and then it gives us the result of that function. We could say print hello name. So now let's give it a little more space here.
That input is designed fair.
What's that?
You don't even have to declare scanner or anything.
Yeah.
It's not even fair.
It's very easy. And by the way, so yeah, it's actually good talking about declaring things. With Python, whatever the first thing that you assign to that variable, that's what it becomes. It's actually a little bit more complex. They actually say that these are not, it's not really a variable, it's what's called a label. I don't want to get into the internal mechanics of how Python handles it. It's a little bit outside of the scope of this class, but the idea is if the first thing I assign to GPA is a number, GPA is just now a float now. If the first thing I assigned to it was this string, it's just a string now. So you never have to write, and you really can't actually, declare a variable as a type. It just knows whatever the first thing you assign to it, that's the type of it.
Oh, it's like a metadata sort of thing.
Kind of. What actually happens is in the background, all that happens is that in memory, there's something that gets a type, and then name is actually a label that points it to it. So name is almost like a reference or a pointer. Right. So name actually never gets a type. It's just a pointer.
Right.
So. Now, what I'll do is I want to know the data type of name, and it should be pretty obvious that it's a string because you're taking in from the keyboard. It just kind of assumes that everything's a string, which is a little bit different than, say, like C++. And that's just sort of to confirm that. Okay, we can see that the thing that I entered in, name, so we got input from the keyboard and said enter your name, store that here in the variable name, said hello name, and that because I entered in my name, that's what it outputted. And just to confirm, we see that, okay, the type of this variable is actually a string, str, which is short for string. That works fine for strings, but there may be times where we want to do something with a number. So say, for example, before we were asking for the GPA, we said that GPA Now, let me ask you this question. Even though we entered in the number 2.5, what do you think that variable is? Do you think it's a string? Or so us as people, we know that 2.5 is a number. We know that it's a float. But do you think Python understands that? Or what do you think it does with it?
Probably turns it into a string because it's in quotations.
Exactly. So and that's just how the input function works. It returns everything as a string because it doesn't know what you want. So it says, a string's very generic. It just holds a bunch of bytes of data. And it just says, hey, I don't know what to do with this. You know how to convert this. So then what you actually need to do, but let's just confirm that first. So we see that the type of GPA is actually a string. So you're correct, exactly. So if we want to do some interesting things on that, let's say, for example, if I wanted to do GPA plus 1, that gets a little tricky because what's a string plus 1? Actually, let's do this. Let's do GPA times 2. This will make a little bit more sense. So let's run this. I enter in the name. So what do you think it did? Yeah, it printed it twice, so it did 2.2, 2.2, which is it's a little bit tough to see from here, but it's 2.2, 2.2. So it thought that by times 2 you meant print that string twice. How do we fix that? What we actually want to do is take that and say, okay, we want GPA, but we want GPA as a float. And so this function, what this will do is this will take whatever it is, usually most likely a string, and it'll do its best to turn it into a float. And the basic idea is that we store things in strings when we just kind of need a blob of some sort of character data. But if we need to do any sort of mathematics, arithmetic, any sort of comparison, anything where that number actually needs to be a number, then we want to actually make it a float. Now, what's an example? Yes?
So does Python automatically make almost everything into a string to start?
Not necessarily. This is very specific to getting input from the user. Okay. In other cases, it usually just you're usually a bit more clear about it, but because like getting data from a user is kind of an unknown, you don't know what the user is trying to send you. They just, because a string is the most generic thing, that's what you put it into. Now now just because something is a number doesn't always mean that you have to store it as a number. So an example of something that, even though it's a number, you might actually not care if it's a number or a string, is a zip code. So think about a zip code. A zip code is technically a number, but I mean, maybe the post office has to do some advanced things, but for most people, are you ever going to have to do arithmetic on a zip code? Are you going to have to compare it to see if a zip code is greater or less than a zip code? Not really. So in that case, that's an example of a number that's probably fine as a string. But if you're doing any sort of mathematics comparisons, like GPA, you might actually want to compare to see if another student's GPA is higher than another student. In that case, you do want that as a number. And so now let's go through that quick exercise again here. And so we'll say that the GPA was 2.5. 2.5 times 2 should be 5. So now it actually did that correctly. So after you get input from the user, if you want to leave it as a string, you don't have to do anything. But if you want to convert it into a float, you have to use this function that takes that and converts it into a float. We're going to start to do more complete examples in a minute. This is just like the very basics. I just need to show you a couple of very like elementary things, and then from there we can actually start to write some programs. So everyone's good with this so far. So let's take a quick step back. So when we print, this is a string. You should remember strings from other programming classes, but the string essentially holds a bunch of characters. Those characters could be letters, numbers, spaces, underscores, parentheses, whatever. This is a variable. We do the variable name. In this case, I just called it name. You can maybe call it first name, so it's a little bit more clear. But whatever we want to call the variable equals, and then whatever data type we give it, in this case, we gave it a string, so that variable is now a string. In this case, we gave the variable number, a float, so that variable became a float. If we ever want to print a variable, what we could do is use these f strings because it makes it a lot more convenient. As we saw from last class, there's actually several different ways to print, but to me this one's by far the most straightforward because all we have to do is put an f in front of it, and you're saying, okay, we want to format this string, and we say anytime we want to put some Python code in here, we just put it in some curly braces and it says, okay, you're doing something special there. If we wanted to, we could actually go to the extreme. We could do like 2 plus 2 in there and it would evaluate it to 4, but 99% of the time you're just stuffing variables in there. And then if you're ever in doubt about the data type of something, remember this special function called type, and it'll actually tell you the type of that variable. Okay. And then here we took some input. Now by default, all the input is going to come in as a string, which is okay sometimes. So there's a function called input, and then we say, okay, give the user some sort of prompt. In this case, the prompt was enter name. And then from there, it gives us whatever they typed in. We're going to store that inside this variable called name. And we just did another one of these f strings here, and we saw that, okay, name was actually a string. But now in this case, where we wanted the entry as a number, we said enter in GPA, and GPA makes sense as a number because we might need to do, well, we'll come back to that. We stored it, but we saw that it starts off as a string. So now to convert it to a number, we have to use this function called float, and that'll give us back a float, and then we store that over in GPA. And now if we try to do, say, arithmetic or multiplication or anything like that, we can. Before, remember we did GPA times 2, it would just give us the GPA. So 2.2, 2.2. But in this case, it actually multiplies it by 2. So in this case, we did 2.5. 2.5 times 2 is 5. Okay, everyone good so far? Yeah, question.
Are there any name conventions for variables?
Yes. So it's what's called snake case. So it's different from Java. We don't do camel case. Everything's lowercase, and then if we have a multi-word something, we do underscores. Now, in practice, I see people violate that all the time, but that's kind of the Python naming convention.
That was like the first thing that like everything that the Java teacher gave me was the camel case thing.
Yeah, that's much more common in the Java and C# worlds. Okay, so let's do another. Everyone's good on copying the code? Okay. So let's keep on going here. Now let's actually start to do something a little bit more useful. So for anybody who's had me with programming classes before, I like to do a lot of these number conversions because they're easy. Most people understand them, but it allows us to kind of explore some of these topics. So if I wanted to convert liters to gallons, all I have to do, let's do one that's simpler. Let's do feet to inches. 1 foot is 12 inches. Okay, so if I wrote a program that converted feet to inches, all I have to do is take in the number of feet times 12. So if a user entered in 3, I want to convert 3 feet to inches, we would take the number 3 times 12, and we get 36. Okay, pretty straightforward. So let's go ahead and write that program. Okay, so the first thing that we're going to do is we're going to say to the user, enter feet. They're going to give us how many feet they want to convert. We've got to store that somewhere. So we'll write feet. Now, what I've told you about this program so far, do you think we're going to want to leave feet as a string, or do you think we're going to want to convert it to a float? Convert. And why do you think we need to convert? So that is the correct answer, and then what's the kind of reasoning? Exactly, we're going to have to do some math on it, and because of that, we need to convert it. So the first thing that I like to do is just do that right away. Oops, sorry, it's not print, enter feet, it's going to be input. Sorry. So for those that didn't see that, I accidentally wrote print. We actually want to input. So I changed it. Okay. So then the first thing that we're going to do is we're going to say that feet is equal to the float version of feet. So we call this function called float, and it'll turn that into a float. And then we do the conversion. We say inches is going to be feet times 12. And then we would print inches. We'll do it as an F string. So if I do 2 feet, that should be 24. When you're testing these programs, don't always just do whole numbers. Think of other things. So for example, maybe 2.5 feet. That should give us 30 inches. It looks like it works. Yes.
For something like that, if you were to have multiple inputs, would the proper format be to turn them into a float after each one's been declared, or is it okay if I label all of them and then turn them all into floats?
So there's no really correct way.
Just
Either is probably fine. For me, I would try to keep. I try to make it valid data as soon as possible, and so
So it'd be like length, and then I would declare it as a float, and then I would do the
yeah.
and then declare that.
That way you don't accidentally enter some code in between when it's an invalid state.
Gotcha.
The other thing that you can do is you could actually, and don't change your code because I'm going to change it back. You could actually do it at the same time because you can nest functions. So you could actually do this and actually get it directly back as a float.
Oh, okay.
Yeah. And in practice, I would probably do something like this.
Just to get used to it.
Yeah. I try not to nest too much in this class because it can be difficult to read. But in practice, I would have probably done that. But this this works for this class. Okay, so let's do this. Try one on your own here. So let's say what if it's simpler the other way? Close enough. Okay, so let's do one that's gallons to liters. So they give us the number of gallons, and then we multiply that. We'll just round. We'll just say 3.78. Close enough. Doesn't really actually need to be exact because we don't really care. So I want you to open up a new tab and then take, let's say, about 5 minutes or so. Let me see if I can get both of these on the screen at the same time. So here's the program for reference. Okay, so just take a few minutes and then try to write essentially that same program, but now convert gallons to liters. Okay, so let's go through the answer. So in this program, we're going, remember how to do a comment. We do this little hash symbol. We're going gallons to liters. Okay, so that means that the user is going to give us gallons. So we're going to say input, enter gallons. And then we're going to store that inside of a variable called gallons. And then because we're going to be doing some sort of numeric stuff with it, we actually want it as a number. So we're going to say gallons is equal to float gallons. So now we have it as a number. From there, we can actually do the conversion. We can say that, okay, liters is equal to the number of gallons times some number, and that number was, I'm looking it up, 3.78. And then we can say liters is, so we'll do it as an F string. One gallon should give us 3.78. 1.5 should give us some number that looks probably correct. I'm not going to check, but I think it is. Doing some quick mental math, that looks correct. Okay, any question about these? Everything good so far? So you get the basics of input and output, converting between data types. And this should be familiar to everyone who's had a previous programming class. How many people feel pretty comfortable with this? It's just different code, but just different, you know, pretty much, okay. So it's just different ways to do the same things that you were doing essentially so far, right? Okay. We'll learn some Python-specific stuff way later in the course, but at the beginning of the course, there's just a lot of like, this is how you did this stuff you already knew how to do in another language. So let's keep on going with these examples. Let's do something now with grabbing two variables from the user. So we'll do the area of a rectangle. Is that how you spell it? I think so. Now, how do I calculate the area of a rectangle? So that'd be for something like cubes. That'd be volume. So for the rectangle, we just need length times width.
Oh, right.
Yeah, that's actually your homework assignment. So you're ahead of the game on that. Let me make sure I use the same terminology, and that I used length and width. Okay. So we know we're going to need the length and width from the user. So let's do that. one of the first things I like to do is just gather all the inputs from the user I know I'm going to need. So we're going to say input, enter length. And then we're going to need to store that somewhere. So we're going to say length. And because we're going to be doing some arithmetic on that, we're going to want it to be a float. And then take a second and do the same thing with width. And then I'll type that in a second, but give you some practice thinking on your own rather than just typing what I type. Okay, so we have the length, the width, now one thing I like to do is this is a pretty short program, we could just write out the whole thing, but I like to test things along the way. So even though my program's not doing much right now, let me at least run it. I've written a few lines of code. So we know at least that much works. It runs. It may not be grabbing the input correctly or anything, but I usually like to write a few lines of code and then make sure that code works. Even if I can't really formally test it or do anything amazing with it, just to, at the very least, make sure it compiles, if nothing else. Now we already stated we want to give the user the area. So at this point we have enough to calculate the area. And what's the area going to be? Length times width. So remember this star symbol. This is how we do multiplication in most programming languages. And then finally, there's not much to it, so we'll just finish out the program. Area is and then run some basic tests. So we'll run 5 times 4 should be 20. See if it's 1.5 times 2. That should be 3. Okay, looks like it's working. Okay, so this is like our breathing point. Let's just take a second. Is there any question or anything that doesn't quite make sense so far? Any of the topics or concepts or anything that we've talked about? Okay, so your homework assignment, the first assignment, normally I like to do 7 or 8 assignments. This semester, what I'm going to do is I'm going to maybe bump it up by 1 or 2 more just so you get a little bit more practice. So I'm going to try to do a couple more. They're not going to be super difficult, but I'm just going to try to throw in some of these every once in a while. So note, so this is your first homework assignment. It's, like I said, it's due in a week, but it's going to be due 11:59 next week. Most people should actually be able to finish it today. I'm going to give you about 15 minutes at the end of class. I think that should be enough for most people. It's going to be based off the example that we just did. So we're going to keep on doing more examples today. Those examples, you don't have to use any of those techniques. So we're going to talk about like if statements and stuff. You don't need any of that. The only thing I'm expecting is what we've covered up to this example right here. Okay? And all you have to do is this is going to be the volume of a box, which is going to be the length times the width times the height. And then I go through and ask, you have to ask the user for those 3 items, calculate the volume, and then output the answer. Now, when you actually go to submit this, what you'll do is you don't have to write anything, but you'll go to attach files, and what do you attach? Inside of REPL, they have, so I'm going to click files. They have a way to actually download this.
I think it's just that save thing on top.
What's that?
There should be a save thing just to run. I think that's how you do it.
So be careful of this. So you can't just give me the URL, because what I've had in the past is what people do is they give me this URL, and then they'll either purposefully or not purposefully change their code. And so they're like, oh, that's not the version I submitted. So what I actually need is the download, the zip. I think I just can't see it because my fonts are so large. Let me,
It's 5 files, the 3 dots.
this right here. Yeah, so click download a zip, and then that'll download a zip file for you. And then you don't need to extract it or anything. If you want to, that's fine. It saves me a little bit of time. But you'll just upload that and then click submit. Okay, and again, we're going to do some more examples today, but all I'm really expecting is the knowledge up to this point, and I'll give you some time. Okay. So any questions on that? Normally, as the assignments get a little bit more difficult, I try to lean toward 2 weeks, but that one's relatively simple, so I think we can do that one and just knock it out. Normally, actually, I would have just said make it due today, but I realize there's some people watching at home, so I want to give them a little bit of time to watch the lecture.
You know, we have to do is add a variable and make variable volume.
Yeah, some of you might already have finished it. So, yeah.
I tried to do what you showed me and input float, but for some reason width won't work when I do that. So I'm getting a syntax.
Let's do this. Do you have time? Do you have a class after this?
No.
Hang out a few minutes after class, and I'll help you individually.
Okay.
Okay, so let's do this. Let's open up another tab. Let's just go through a couple more things. Maybe just one more thing. That would be a good stopping point for today. So we've covered input and output. So basically printing and then the input function, getting input from the user. We've talked about variables, the data types of variables, converting variables, all that sort of stuff. But a program that just works with variables isn't that interesting. The nice thing about programming is that we can do conditional things. So what I mean by that is if statements. If some condition is true, do something. Okay? So let's take a simple example. Let's say, for example, if we want to, if we're doing a voter registration system and we want to know that the person's actually 18 years old, we'll let them register to vote. Okay? So let's do this. The first thing that we're going to ask of the user is their age. Now again, do you think I should leave this as a string, or do you think it might be useful to convert it to a number? Number, yeah. And now in this case, we actually don't need to convert it to a float. We can convert it to something called an int. And the main difference between ints and floats are ints are whole numbers, positive and negative whole numbers. Now in this case, I don't actually really care if the person's 18 and a half. I just really care about their whole number age. So just so we get a little bit more practice doing other things, let's rather than doing it as a float, let's say that age is now going to be an integer, an int. Again, an int is just positive and negative whole numbers versus floats, where you can think of as positive and negative decimal numbers. And again, we want to try to run our code as frequently as possible. So let's go ahead and enter in an age. Perfect. And just to be clear, you can see that it's an integer. But we don't really need to keep that around. We kind of already know that. So let's talk about if statements. Now this is in Python where we start to get into, so in most other languages, C-based languages, we use a lot of curly braces and we use semicolons, okay? Semicolons let us know the end of the line. Remember in Python, notice that we don't have any semicolons. It's just because one line, as soon as we hit the enter key, that means that we have a new line. With if statements, it's kind of the same thing. We don't have curly braces with if statements. So say, for example, if we wanted to check if the user is greater or equal to 18, we say, hey, you're old enough to vote. Otherwise, you're not old enough. So let's convert that to code. Everyone still remembers if statements from programming classes previously, right? Does anybody need a quick review of if statements? You kind of remember how they basically work? Okay. So the idea of an if statement is that if some condition is true, in this case we want to know if the age is greater or equal to 18. So I think, again, most people know if statements, but this is probably a little bit different to you because we don't have parentheses, we don't have curly braces. So in Python, the parentheses are optional inside of your if statement, and generally, unless it's a very complex if statement, we leave it off. So let's say if the person is 19, they can vote. Let's check the edge case, make sure that 18, if they're 18 exactly, they can vote. That works as well. Now notice that rather than the curly braces, we have a colon. So that's, rather than curly braces, the idea is we try to make the code more readable, and many years ago they decided that this makes the code more readable. And rather than curly braces, what you do is you indent your code. You hit the tab key. Now what happens if I don't? It doesn't compile. This is probably very strange for many of you because most other languages, just hitting the spacebar or the tab key a couple times isn't going to break your code. But Python is very specific that when you have code blocks like if statements and for loops and functions and stuff like that, rather than using the curly braces, we indent. And so if we had multiple things, it kind of, the IDE gives us a little visual cue here. Notice the line. And then if we had something that was outside of the if statement, we just don't indent. So regardless of their age, this is going to always print. So if they're, again, if they're 18, those two lines printed plus this. But if that's not true, it just went right to end of program. This is the thing that really throws people off for quite a few reasons. One of them, if you copy and paste code off the internet, like say like a Stack Overflow or something like that, you have to be very, very, very careful because the spacing is important. In other languages, you can get away with copying and pasting a lot. With Python, you have to be very careful. And it's very specific. So if I did something like this, it's already telling us it's not going to compile. The reason that they did this is that this is considered good practice in all languages anyway. But with Python, what they decided to do was actually make it the language syntax. So with other languages, it's good practice to do this, but the code will still compile if you don't. With Python, you have to write it like this or the code just won't compile. So again, we have an if statement, no parentheses, and rather than the curly braces, we put a colon. And then anything belonging to that if statement, we indent at one level. Now you probably remember if statements are often, we have an else with it. So let's just go ahead and throw in our else. And same thing here, we do else, colon, and then we indent one level. So let's just test both cases now. So if they're 17, now it should say you cannot vote. Perfect. If they're 18, it tells them they can vote and to go fill out the ballot. But regardless, because this is not indented at all, this executes no matter what. It's not part of the if and else. Okay. And I think that's a good stopping point for today. So I'll let you catch up on typing that out. Let me know if there's any examples you want me to put on screen. Now, what I do is, in case there was an example that you were just completely lost, or you're not typing, or you're just not quite getting it, I usually will take all the code examples that we did for the day, and I'll put them on Blackboard. It might take me a couple hours because I'm teaching another class today, but you'll have that available as well. You have the lecture. But so what we'll do is finish any typing, and then we have about 15 minutes left. Last 15 minutes, you can just work on the assignment, and I'll help anybody individually who needs help with either the assignment or getting it submitted on Blackboard. Okay, so I don't really need to stream anymore. Does anybody have any questions that you might want answered recorded?